Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and the concepts of condensed matter physics. So I hope that the discussion which we have done till now in our previous classes that will be clear to every one of you. But in case if there will be anybody having any doubt anywhere in the discussion we have done till now, you can surely let me know about it and we will try to consider those points here in the session then. But if everything is clear to every one of you, then that's great. So let me know if in case you are going to have any question, query or doubt from the previous classes discussion. I will be trying to consider those points first of all here in the session. And if everything is clear, then that's great. So guys, this is going to be our important concept session for the condensed matter physics. First of all, I would like to show you some important slides here in the session, and after that we will be continuing the discussion. So here we are going to have the slide regarding the iconic subscription. So what are the benefits you will get if you will be taking the iconic subscription? They have been shown here on the slide. And guys, even notes are now available on the learning app, which will be helping you a lot to take your preparation to the next level. Along with that guys, all these important benefits which you will be getting there when you will be proceeding further to take the subscription, so that has been shown here on the slide. And whenever anybody will proceed further to take the subscription, use and apply the referral code that's Anjali Live as mentioned here on the screen to get the discount in the total subscription amount. Same way, we are going to have the important notes available on the learning app. Even if you will take the plus subscription, you will be able to check them out. And guys, all the other benefits you will be getting when you will take the subscription have been shown here on the screen. So you can use the referral code Anjali Live to get the discount in the total subscription amount. And this is regarding the light subscription. This is regarding the plus iconic and the light subscription. So you will be able to check out the important notes in the like after taking the subscription, and that's how everything will be helping you, even along with the sessions we will have by the top educators. You will be able to find these important things there, okay, as they have been mentioned in the respective sections and the particular subscription. So whenever you will proceed further to take the subscription, use and apply the referral code that's Anjali Live to grab the offer, clear, or to get the discount in the total subscription amount. So now again, I'm just going to show you quickly some of the other slides. Like this one is regarding the Unacademy subscription, okay, and about the Unacademy learning app. This is about this particular session. This is going to be some information about me. Here we are having something related to community feature we are having on Unacademy. So this will be helping you to get the latest updates regarding the new courses and important courses, and that's how everything will be helping you a lot. What we will do now in today's session, we are going to take important questions along with the concepts. So that's how we will be continuing the discussion. In case if you will be having any question or query or anything you want to ask, you can surely let me know about it. We will be trying to consider those points in the session. But if everything will be getting clear to you, then that's great. So let's take the first question in the session right now. And if in case you will not be familiar with these important concepts which we have to consider to solve these questions, I'll be helping you in that case. So the first question is, in a band structure, calculation, the dispersion relation for electrons is found to be, that is epsilon k is equal to beta cos kxa plus cos kya plus cos kza. Okay, next thing is where beta is a constant and A is the lattice constant. The effective mass at the boundary, the effective mass at the boundary of the first billion zone is. Options I'll be writing here. So that's going to be option A is 2h square upon 5 beta a square. Option B is 4h square upon 5 beta a square. Option C is h square upon 2 beta a square. And option D is h square upon 3 beta a square. Now you can try solving it and let me know as you will get it done. If in case there will be any doubt anybody will have, we will be talking about that point too. But if you will be getting it, that's gonna be great. So you can start working on this part and let me know what will be the right answer according to you. I'm just gonna wait for your reply, and after that I will even be starting the discussion about it. So actually guys, they have given you in a band structure calculation. Give me a second, let me just check whether everything is all right or not. I think everything is fine and clear, so we can continue the discussion then. Okay, so they have given in a band structure calculation that is Pearson relation for electrons is found to be epsilon k, that is equal to beta cos kxa plus cos kya plus cos kza. Where beta is a constant and a is the lattice constant, the effective mass at the boundary of the first billion zone you have to find. So do you know about the formula of effective mass, which is m star is equal to, this is what we take the notation for the effective mass, h square upon delta to E upon delta K square. And where they have asked you to find it? At the boundary of the first Brillouin zone. So what will be the boundary of the first Brillouin zone? At Kx, Ky, Kz is equal to plus minus pi by a. Okay, so that's how you have to consider it. But since they didn't specify whether plus pi by a or minus pi by a, so you will go for plus pi by a. That's what you have to do. Next thing is, if we are going to consider it to be this way, h square upon, so our first target will be to find the delta to E upon delta K square. There is epsilon K is the E here they have taken. Now, so when I will be considering the further calculation part, I'll be getting a square, then with the negative sign cos kxa, the other one minus a square cos kya, then another one minus a square cos kza. I can take the negative sign a square beta like outside, and I will have just cos kxa, cos kya, cos kza. When I will be putting the value pi by a, pi by a, pi by a, at place of kx, ky, kz, I'll be just getting cos pi, which is minus 1. So minus minus plus 3 beta a square you will have there. So what will happen in this case, 3 beta a square is gonna be at this particular place after putting all the values. So now you can see what will be your right answer you will have. That's option D. This is how you will simply be getting it. Now you can see that what steps I have taken, how I have just put the values, how I have considered all the steps here. So that's how you are going to get everything. Let me know if in case there will be anybody having any doubt. We can surely talk about that part. But if everything is clear till this point, we can go for the next question. So mainly in the previous question, you have to consider the effective mass formula, which is going to be this, and the condition for the first Brillouin zone boundary, this. And if you know that, I think it's gonna be quite simple and easy for you to get the answer. So here is the next question for you guys. That's going to be the radius of the Fermi sphere of free electrons in a monovalent metal with an FCC structure in which the volume of the unit cell is A cube is. Now the options they have given are 12 pi square upon A cube to the power 1 by 3. Option B is 3 pi square upon A cube to the power 1 by 3. Option C is pi square upon A cube to the power 1 by 3. And option D is 1 upon A. Check it out. What do you think will be the right answer and how you will be proceeding further? If in case there will be any doubt you will have, I'll be explaining that point. I'll be making it clear to you. But if you will be able to get it, that's great. So I'm going to wait for your reply here and you can tell me whether there is any doubt you are going to have or everything is clear to you. Okay? So just check it out and let me know about it. Try. What do you think will be the right answer? The radius of the Fermi sphere of free electrons in a monovalent metal with an FCC structure. So once you got to know about the FCC structure, the effective number of atoms you will have there will be 4, okay? In which the volume of the unit cell is A cube. So that's what is the information you are going to have. So you need to know about this part, that the radius of the Fermi sphere is same as the Fermi wave vector, which is kf. And since FCC case they are talking about, which is a 3D case, so for that the kf formula is 3 pi square n upon, that's going to be v to the power 1 by 3. Clear? Now n is what? 4 in case of the FCC, okay, and v is equal to a cube. So what you will have, that's going to be 4 3s are 12 pi square upon a cube to the power 1 by 3. Hence your option A will be the correct option you will have. Please tell me if in case there is anybody having any doubt, which is like whichever point is there which is not clear to you, you can just mention it, we can talk about that. But if everything is clear, then that's great. So let me know if there is something you want me to discuss or consider. I hope it's clear till this point then. Let's go for the next question too. The next question is, I'll be writing it here. This one. The energy of an electron in a band as a function of its wave vector k is given by Ek is equal to E naught minus B cos kxa plus cos kya plus cos kza where E naught, B, and A are constants, the effective mass of the electron near the bottom of the band is. That's your question. And the options are 2h squared square upon 3ba square, 2h squared square upon 3ba square. Option B is h squared square upon 3ba square. Option C is h squared square upon 2ba square. Option D is h squared square upon ba square. That's what you are gonna have. Try it now and let me know as you will get it done. What will be the right option according to you? Waiting for your reply for some time, and then I'll be continuing the discussion about it too. I will be waiting for what you're gonna get or what is the right answer according to you, and then we'll be continuing the discussion too. Mm-hmm. Okay, guys, let's even talk about it. The energy of an electron in a band as a function of its wave vector k is given by Ek is equal to E naught minus B cos kxa plus cos kya plus cos kza. So where E naught, B and A are constants, the effective mass of the electron near the bottom of the band will be what? Okay, so in this case, what will happen when they have mentioned near the bottom of the band? What is the meaning of this part? So when they are saying near the bottom of the band, it means it's going to be k tending to 0, because now you have to understand this part. See, it is going to be, the band is something like this, omega versus k. So when near the bottom, it's not at the bottom. There is a difference between the two statements. At the bottom, near the bottom. Near the bottom means k just tend to 0. At the bottom means k will be equal to 0. I hope everybody is getting this. Now the next thing is, once you're going to consider it, it's going to be cos kxa, which is going to be 1 minus kxa whole square upon 2. Because for smaller value of theta, you can write the cos theta as 1 minus theta square upon 2. And for smaller value of theta for this part as well, you will be writing the same thing. That is 1 minus ky square upon 2. Otherwise, if you will start differentiating it, then your expression may get changed. You may be getting something else. So what we will do, we will prefer to do this change the value we will be considering initially, so that we will not have any confusion later on. Now you will be having some expression. Now if you want to differentiate it twice with respect to kx, ky, kz, so you will be getting just what? 2kx a square will be remaining there. Okay, then 2a square. So that's how you will be having everywhere 2a square. uh, the next one will also be the same, and the next one will also be the same. So what you can do, you can take 2 common actually. Okay, so you will be having 2ba square with you. So once you have got that 2ba square, you know effective mass is what? That's h squared square upon uh once again, let me just check it out. Like, are you exactly going to get same or something else? You have got k square a square kx square a square upon 2 now. Now when you are differentiating it, you are going to have the half part there. Is it so? Like, let me just check. Yeah, 1 upon 2 is already there. So in the numerator, whatever 2 you are getting, you will be able to cancel it out with that 2, because you have replaced the cos theta with 1 minus theta square upon 2. So just you will have ba square in the denominator. So you will be getting h squared square upon ba square, and that's how your option D will be correct. It is exactly similar to the first question we have taken, but the condition is different, and that is this time near the bottom of the band, and for that case k will be tending to 0, and we are replacing cos theta with 1 minus theta square upon 2. I hope you're gonna get it, but in case if there will be any doubt, you will have just mentioned that part. I will be talking about it too, and we can consider that part this way. Okay, just let me know if there is any question you are gonna have from this part. I'll be considering it and we can talk about it. If everything is clear, I'm gonna give you the next question now. Okay, let's take the next one. The dispersion relation that's going to be for electrons in an FCC crystal is given in the tight binding approximation by epsilon k is equal to minus 4 epsilon naught cos kxa by 2. Next you're going to have is cos kya by 2, then plus cos kya by 2 and cos kza by 2, then plus cos kza by 2 cos kxa by 2. That's what you will have now. Clear? Now the next thing, where A is the lattice constant and epsilon naught is a constant with the dimension of energy. The x component of the velocity of the electron at pi by a comma 0 is Options are minus 2 epsilon naught A by h cut. Option B is 2 epsilon naught A by h cut. Option C is minus 4 epsilon naught A by h cut. And option D is 4 epsilon naught A by h cut. That's what we are going to have. Clear? Now, you can consider what they have asked you to find and how you can proceed further. Accordingly, you can take the steps and let me know what will be the right answer according to you. If you will not be getting it, I will help you in that case, but initially I'm going to give you some time to work on this part and to let me know like what are the steps you have to take and how you will be able to get your answer. Okay, guys, let's talk about it. So they have given the dispersion relation for electrons in an FCC crystal is given in the tight binding approximation by this. Basically, we call it the dispersion relation because it is the relation between epsilon and k. And then you are having the expression mentioned there where a is the lattice constant and epsilon naught is a constant with the dimension of energy. The x component of velocity you want to find, so which is simply going to be what is the velocity you will have. That's v is equal to 1 upon h cut dE or d epsilon upon dk. Okay, now you just want to find the x component, so you will just be differentiating it with respect to kx. So you can take it kx here. Now whatever you will get, what you have to do next, so whatever you will be getting here, just put the values of kx, ky, z, ky, kz as pi by a 0, 0. Once you will take that, once you will be getting that answer, that will be 4 epsilon naught a upon h cut, and it's gonna match with option D. So this is how you will be reaching to the final answer. If still somebody is having any doubt in this part, just mention it. I can consider that too. But if everything is clear till this point, then that's great. So just mention it, guys. If in case you are not gonna get something or you are going to have any doubt anywhere in the discussion we have done till now in this session, okay, so what we will do, we are gonna consider this much only, but in case if there will be any doubt anybody will have and something you want me to explain again, you can surely tell me about it, okay? Or if you're not able to get the answer for this question, we can talk about that too. So let me know whether everything is all right and clear or not. If no, we can consider it. If yes, that's great. So this was something important from the condensed matter physics, like whatever we have talked about and we have considered in the session. Now, if you have worked on all these questions I have taken in the session today, you got to know about the basics, even you got to know about what is important and from which section you can have the questions in the exam too. Clear? So that's something really important for your upcoming exams, and that idea once you have got, it will be helping you a lot. So we will be keeping it this much, but if you want to attend more important sessions, you can keep on attending or joining these sessions, as we will have so many important sessions in upcoming days. So don't miss them, okay? And join these sessions too. Even I'm gonna conduct the special classes. These are the free live classes on Unacademy Learning app, And guys, the plus courses are even going on, and so many new plus courses and the batch courses will be starting in upcoming days on Unacademy. So you can even enroll in them after taking the subscription. So if you think you want to take the iconic subscription, as you can check out all the benefits you will be getting if you will take the iconic subscription, they have been shown here on the screen. And whenever you will proceed further to take the subscription, use and apply the referral code, that's Anjali A Live, to grab this like to get the discount in the total subscription amount and get the all the benefits as shown here. Also guys, another thing is, if you will take the plus subscription, what are the benefits you will be getting, all that has been shown here on the slide too. This is about the light subscription, this is about the plus iconic and the light subscription. So all the details have been shown here on the slide. I hope each and everything is getting clear to everyone, but in case if you will have any question, query or doubt, you can surely let me know about it. Let's keep it this much right now. Thank you so much everyone for joining this session and for attending it till the end. Thank you. Let's keep it this much. And yeah, we will be having so many other sessions too here, as well as on Unacademy Learning app, so you can join them as well.